Worksheet 16A combined loading. Given a circular solid shaft shown, so they have a fixed end, fixed support, and there are two load, the torsion T, 40-inch kips, and the axle load, 50 kips as shown there, and the radius of the shaft is 2 inches, and the XYZ axis they define that way. And the question is determine the reactions at the fixed end. Determine the reaction at fixed ends. So we can draw the free body diagram for that shaft to determine the reaction at fixed end. So free body diagram. And we have XYZ. So in here, the load app P 50 kips, and we have a torsion at one end 40 in kips, and the question is what is the reaction at the fixed end. And you see for the fixed in 3D there are 6 unknowns, and with the definition of x void and in there as void, so we can have the unknowns. The first one, that is reaction at the unknowns, because that is reaction, force reaction X, and of course with the XYZ that they find out, wrote out X, Z, and Y-axis as shown in the problem. So you will have that Rx, and we have Ry, we have Rz, and then of course we have a associated moment, and let assume follow the right hand rule. So that is Mx, Mz, and My. So 6 unknown, as you know. So let's find out the external forces with the equilibrium equation. Sum of all the force in X equal to 0, and that, as you can see, equal to 50. Follow right hand rule. Let me write down here for the positive right hand rule. Rx, then we have Rx equal to 50 kips, and the 50 kips there, as you can see, it will be opposite of x-axis, and then positive 50, it means that same as our assumed direction as shown in the free body diagram. Sum of all the force in y direction equals 0, and it will be Ry, and that means Ry equal to 0. Similarly, sum of all the force in Z equal to 0. Z reaction at about the Z axis, and Rz equal to 0. And now talk about the moment. Sum of all the moment about X, and follow the right hand rule. If you have the X here, positive X, and that is positive right hand rule, so we have the sum of all the moment about X equals 0, and that is the 50 kips, the 40-inch kip. Follow the right hand rule, it's negative, as you can see, negative 40, and I will assume for the reaction is positive follow the right hand rule. So it means that mx reaction at x equal to 40 inch kips and positive based on the right hand rule. Similarly, we can do with the sum of all the moment in y direction equal to 0, and the y axis is positive y, so we assume the right hand rule for that one. It will be here, and of course that one there nothing, 0 equal to my, it means my equal to 0. And similarly, we have sum all the moment about z equal to 0, follow the right hand rule. Let's see, the y axis is vertical up here, then the that is positive moment, and that equal to mz, and that we have mz equal to 0. So bottom line only have fx reaction at the fixed support 50 kips and mx equal to 40 inch kips with that equation here. And from that, go to the part B and C. Determine state of stress at point A given the load in shown where point A on the top edge of the member, so that is point A. So that is point A. Given the load in shown, determine sigma x, sigma y, sigma z, tau x y, tau x z, and tau yz, and draw the state of stress block or the 3D stress scoop and label stresses at A, and draw the Mohr circle for the stresses at xy plane. So basically that go back to combined loading that we have two type of load here, the torsion and the normal force. Go back to review what we have here with different time of load, we create different internal forces and stresses, and then the analysis procedure that we have, external load, forces that we just did, and then now you can see the next step, two internal forces, and then we do the stresses, and that you superposition so that we can consider one stress at a time and add on the stress block and evaluate performance. So the next step, as you can see, step 3, and then step 2, and then 3, internal forces and then stress. So let's go to here. The next step, it will be internal forces at A. A that we have, so we can cut that member here through A, right? To find out internal force, we have to cut that member of interest at the point. So let's cut and consider the top right. Consider the top right. So this is point A. We have point A here. Point A. So at the reaction at the fixed end, we have the Rx equal to 50 kips, and the couple the torsion for the inch kips 40 inch kips. So in the internal reaction at A, as you can see, there is basically 6 unknown in there. Okay, 6 unknown because that's 3D. So let me write down the first one. We have Ax, of course, and I follow the XYZ. So you have Y, Z. Sorry, that is X. Z. So we have that, and we have AY, because we have AZ, and then we have moment, follow the right hand rule, mx, mz, my. And similarly, we have sum of all the force in x direction, follow the follow the positive x-axis equal to 0, and from that we can have ax minus 50, so ax equal to positive 50 gibbs. And of course, very quickly, y equals 0 equal to ay equal to 0. And sum of all the force in z direction equals 0, and it az, so az equals 0. And of course, we can be able to apply the moment, sum of all the moment about x, and assume that x and right hand rule positive equals 0, and that, as you can see, it will be mx minus mx plus 40. It both positive based on our assumption, so it mx is equal to 40 negative in gibbs, so it's opposite to our direction, and that this one is actually the torsion, because rotation, the moment rotation about the axis, the longitudinal axis of the shaft, so that we call that is the torsion, if you have there, right, torsion. And we also have sum of all the moment about y and y-axis here, and positive follow right hand rule. We have 0 equal to my, so my equal to 0. And of course, we have sum of all the moment about z equals 0. Assume right hand root positive, so equal to mz. So moment reaction about z-axis at A, and mz equal to 0. So only two that we have here is the ax 50 kips and mx, which is the torsion, because that moment rotation about the longitudinal axis of the shaft, so that the internal forces. And with that, we done for the first two steps, external forces and internal forces. Next step, we do the stresses and more circle.